All right, just so for the next people starting the video, we'll just key this one out. So we had 7, 1, and we ended up at 1, -5, not to scale, but the start and the end. So the starting point have a solid dot, the ending point would have an arrowhead on it. Looks good to me. This vector, starting from the origin, moves left 2, down 3. So we're going to go left 2, down 3. So it looks like that. And then this one has a length of 5 and travels 212 degrees. So let me do a quick bit of math. Let's see, 180 plus 32 gets me my 212. So it's going to be about 32 degrees beyond the axis. That looks a bit much, actually. That looks like 45. Let's try this. That looks a bit better. Right? And as long as I mark this with a 5, I mark that with a 212, I get all my credit. All right, let's move on. So now the next objective is going to be calculating magnitude. So one time, magnitude is a fancy word for length of your vector. So if I were to calculate the length of my original vector that I had in my point, what I would know is in a 3-dimensional world, we see in 2 dimensions, right? So everything has a horizontal component and a vertical component. So I want you to start thinking about where you started. I started at 2 and ended up at -3. So without doing any subtraction, without learning any formula, common sense says I traveled left 5 units and I traveled down from 5 to 1. I traveled down 4 units. So I traveled left 5, down 4. Now, horizontal and vertical are perpendicular to each other. So look what I've just created. I've created a right triangle. And the vector is the hypotenuse of the triangle. So using Pythagoras' theorem, find the length of all 3 of your vectors, please. Okay. So I'll put that back up. I'll put your 3 vectors right there. Actually, I'm just gonna let the video run, and we'll just do 2 videos, and they can. So people just do a pause and fast forward. Or fast forward, I mean.
You go this way or this way? Right 7. You go back 1, so 6. It's like 6.
Yeah. You have brave ahead. That's a yeah, right. I don't know. I never see this one.
Yeah.
You're still going to get the same answer.
Yeah.
I had to go work. Less 60.
Be about
Okay, I thought
bigger
it
than
was-
8.
I did say
Square root of 69
I
is
said
8. Okay. See what I just did? Alright. 6 squared, 6 squared. Yeah, it's going to be 8.
Is it 6 of
Hang on. Oh, from which one are you doing? First one. So you're going left 6, down 6. I moved it back up. So left 6, down 6. What do you get?
Yeah.
Because you're left 6, down 6. Right? So from 7 to 1, from 7 to 1 is 6. So that's 6. And then from 1 to -5 is 6. So 6 squared plus 6 squared. Square root of 72. So it's got to be well, you were thinking of. Well, you tell me. Kind of a trick question. What's the length? It's in the problem. It's like saying who wrote Tchaikovsky's Fifth Symphony? Tchaikovsky. Who taught Mr. Burton's class on theory? Burton. I mean, like, how long? It's 5. It's 5. Yeah, be quick with your angle, and that's a good one. Well, you did it yesterday. Same thing, inversely. Yes. Oh yeah, right. You want your quizzes for tomorrow. Correct.
All right, so let's do a quick. Is still recording? Yes. So just to do a quick check. All right, let's get through this, please. I think everyone in here got it right. Just for quick of anyone watching a video, real quick. So we went left 6, down 6, square root of 36 plus 30. We all can do Pythagoras' theorem. Square root of 72. Square root of 69 is 8, so it's 8 point something. Type it into a calculator. 8 point what? I'm going to say 485. Okay. All right. So, and hopefully I heard you right. So, this one is left 2, down 3. So in my head, 4 plus 9, right? 2 squared, 3 squared. So that's 13. Square root 13. 3 point what?
606.
Thanks, sir. And then this one, kind of a trick question. It's just 5. The length is already given within the problem. Okay, so, all right, now last but not least, let's, last bit of objective is we are going to calculate So you're learning to speak math, so in your head you convert that to angle. That's all there is to it. So let me just do, for this unit, you pretty much could have skipped all of Algebra 2. You can just come from geometry right into this section and you'd be fine, right? Because because back from geometry, you know SOHCAHTOA. And if I have, let's go up to my original statements. Okay, here. So if I have a left 5 and down 4, I know that this angle right here is the tangent of theta is -4 over -5. Now, what you also learned in geometry, and we've done in this class, is that you can use the inverse to find the angle, because right now the angle's unknown and it's tucked inside the function. So if you take the inverse tangent of switch the input and the output, the domain and the range, so if you put 4 over 5, I'm being lazy there. Well, I'm not being lazy. -4 over -5 is a positive. It doesn't matter if you turn -5, it will give you the same answer. It doesn't matter. But I'm going to go ahead and do it the way I would suggest you do it. All right, so there we go. So now we're going to be lied to, because anytime you go left, as soon as you see a left in the vector, -5, you're going to be lied to, because tangent only spits out from -pi over 2, pi over 2, and we can say from -90 to 90. And we know we're left and down, so that's going to be beyond 90. So let's go ahead and do it, and everyone follow along. So please type that into your calculator, and then make sure you should still be in degree mode, because we've been doing that in degrees for quite a while. So we want the inverse tangent of 4/5 I got 38.660 degrees. All right. If I wanted to be wrong on the quiz, which you don't want to be, I would just circle that. But it's wrong because look why we're drawing the vectors. That vector is going left and down. There's absolutely no way it can be a 38 degrees in quadrant 1. It just can't be. So from yesterday, what do I have to add to that? Add 180 to that. So go ahead and do that for me, 180. That gets you your 218.660. Now let's just check reasonable just to make sure. Is that pointing down into quadrant 3, 218 degrees? Yes, it is. We're all good. All right. So to finish up the day, which is probably a little light, we maybe answer some questions. Finish up the day. Please find the angle for your problems, please. Actually, yes. The lesson will be to find these two. This one's obvious because it's given. But what I want you to do is challenge yourself, and without me teaching it, I will teach it tomorrow or whenever, soon, but I want you to get this vector, I want you to turn it into component form. Draw it out, think about it, just see what you and your neighbor can come up with, right? So without me teaching, before that lesson comes, see if you can turn vector C into component form. Anyone got a question of what to do before I stop the video? Like what turning into component form means? Okay, good. We're done for that. You guys, and I'll come around and monitor you.